Good afternoon, SM2A. Today, we are going to discuss about Fano's geometry. First of all, let us all know who is Gino Fano. Gino Fano was an Italian mathematician best known as the founder of finite geometry. He was born to a wealthy Jewish family in Mantua, in Italy, and died in Verona, also in Italy. Fano made various contributions on projective and algebraic geometry. A finite geometry is a geometry with a finite number of points. When confined to a plane, all finite geometries are either projective plane geometries with no parallel lines or affine plane geometries with parallel lines. If one of you were going to ask me, Mom, what is finite geometry used for? Well, finite geometry is intimately linked with experimental design, information security, particle physics, and coding theory. Apart from being an exciting and interesting areas in combinators, finite geometry has many applications to algebraic geometry, theory, codes, graphs, and designs. In finite geometry, the Fano plane, named after Gino Fano, is a finite projective plane with the smallest possible number of points and lines. There are 7 points and 7 lines, with 3 points on every line and 3 lines through every point.
In Fano's geometry, we have 5 axioms and 2 theorems. The axioms are: Axiom 1, there exists at least 1 line. In Axiom 2, there exists exactly 3 points in every line. Axiom 3, not all points lie on the same line. Axiom 4, for each 2 distinct points, there exists a unique line containing both of them. Axiom 5, all lines intersect. There are no parallel lines. So today, we are going to discuss it one by one.
So today we are going to talk about something called Fano geometry. And whenever you have your new geometry, you want to take a look at the axioms and internalize those, because those are your new rules defining your geometric universe, right? So the axis we have for Fano geometry, axiom 1,
there exists at least 1 line.
So next axiom natin is axiom 2. So axiom 2 said that each line has exactly 3 points. So as we can see here, we already have 1 line, and then we'd better have 3 points in this line. For example, this line, which is line 1, and there exists a point which are point A, point B, and point C. So on the following slide, makikita natin doon ang model of Fano's geometry. So sabi dito, each line has exactly 3 points. So makikita doon ang 7 distinct line including 1 curved line. So lahat yun ng 7 distinct line na yun ay merong exactly 3 points each. So on the other hand, note that the axiom says nothing about whether the line is straight or curve, as long daw as nagko-contain ito ng exactly 3 points each.
Okay, since we're done sa ating axiom number 2, let's proceed sa ating next axiom, axiom number 3. Not all points lie on the same line. So, kung makikita po natin, meron tayo dyang line 1 which has 3 points A, B, and C, and then to create another line, we need to add another 1 point dyan sa may itaas na bahagi. It will be our point D. So, since we have point D here sa itaas, masasabi natin na not all points lie on the same line because only point A, B, and C, sila lang po yung nasa isang line while yung D na yan na nasa itaas is nakapahiwalay po siya. Hindi siya kasama sa line A, B, and C. Ayan po yung ating axiom number 3 and sana po naintindihan niyo po.
Before we proceed to the axiom 4, let we go back to the axiom 2, which is every line there exists 3 points. So as you can see, we created lines here, which is the line 2, line 3, and line 4. So let us put points in each line to satisfy the axiom 2. That is point E, point F, and point G. So let's proceed to the axiom 4. For each two distinct line, there exists a unique line containing both of them. So as you can see, meron pa dyan mga points na hindi pa connected. So, ang gagawin natin ay i-connect natin yon para makakreate tayo ng another line. So, i-connect natin yung point G, F, and A, and another line, point E, F, and C. So, we created another two line, which is the line 5 and the line 6.
So in axiom 5, all lines intersect. There are no parallel lines. So in axiom 5, there no line that not intersect. As you can see, line 1 and line 2, the intersection is point E, and line 6 and line 4. The intersection is point C. Line 2 and line 4, the intersection is point D. So, sa nakikita nyo, wala talagang line na parallel kasi lahat sila ay nag-intersect. And then, sa nakikita nyo, mayroon pa dyang mga points na hindi pa connected to each other. So, ang hindi pa po connected dyan is yung point G, point B, and point E. So, yung gagawin po natin ngayon is i-connect po natin para makabuo po tayo ng another line, which is ito po is yung line 7. Kung nagtataka kayo kung bakit ganyan yung line 7, dahil curved line is also considered as a line. That's axiom 5.
Fano's geometry has exact 7 lines. Suppose Fano's geometry had a line that was not among the 7 we've established. By axiom 4, each 2 points must have exact 1 line. On both of them can contains at most 1 of these 7 points by axiom 2. Though contains 3 points, therefore contains at least 2 points that are not among the original 7. This contradicts our previous argument that there are exact 7 points in a geometry. Having now constructed 7 lines, we argue by contradiction that there are no others. We therefore suppose that line is an 8th line. Axiom 2 ensures that the lines contains 3 distinct points. In particular, lines contain some pairs of distinct points. We have already constructed a line containing any pair of distinct points. So, axiom 4 implies that line must in fact coincide with one of the 7 lines already found. A contradiction no such line can exist, and we may conclude that Fano's geometry has exact 7 lines. We can verify the assertion by inspections since we have already given a construction of all points and lines in Fano's geometry. It is also possible to give an argument more along the lines of the one used to prove the theorem. Let point be any point, not necessarily the point previously denoted by point. So, as you can see, the model of our Fano's geometry here. So, isa-isahin natin yung mga lines. Line 1, dito sa banda sa may ibaba. Line 2, dito sa gilid. Line 3, itong line na nasa gitna. Line 4, itong line sa nasa gilid na right. Line 5, ito. Line 6, ito. And line 7, itong curved line. So, napatunayan natin na ang Fano's geometry has exact 7 lines.
Theorem 2, Fano's geometry has exactly 7 points. To prove this, we will use an argument by contradictions. In the constructed plane, we can see that there are at least 7 points, and those points are point A, point B, point C, point D, point E, point F, and point G. So, dahil gagamit tayo ng arguments by contradictions, so kunwari magdadagdag tayo ng another points which is point H. So, dahil nagdagdag tayo ng another point which is yung point H, so magkakaroon din tayo ng another line which is magiging line 8 na siya, consisting of point A and point H. So, ang line 8 natin intersects in line 1, line 2, and line 5 as they both met and point A. So, in action 2, it is stated that there exist exactly 3 points on every line. Kaya, in between H and A, mayroon dong third point which is considered as point I. But that point, which is yung point I natin, hindi siya considered in any of A points since this could contradict an action 4. Moreover, kapag dinagdagan pa natin ng H, ng point H, ng ating Fano's plane, then that plane, and then that point or line between H and A would be parallel to at least 2 other lines in our geometry which violate action 5. Like for example, yung line 8 natin. So, magiging parallel siya into line 7 consisting of point EBG and line 3 which is point BFB and the line 4 CGD. So, therefore, there is no 8 points in Fano's geometry. So, Fano's geometry must have exactly 7 points and more than 7 points has no possibility.
To sum up, Fano plane defined as the smallest finite project plane because a Fano plane is said to have order of 2. Next is a finite plane of order n has n plus 1 points on each line for projective plane. Meaning, on each line of projective plane, it has n plus 1 points. No? So, sa bawat line daw ng projective plane, merong n plus 1 points. So, isa-substitute natin ngayon yung 2, 'di ba? Since yung order daw ng Fano plane is 2, so isa-substitute natin ngayon yung 2 dun sa n. So, magiging 2 plus 1 siya. 2 plus 1 equals 3 points. So, sa each line ng Fano plane, mayroong 3 points. Sa bawat line ng Fano plane A, mayroong 3 points. Which is, pasok siya doon sa axiom 2 na diniscuss natin ni Miss Apgao. So, next is, a projective plane of order n has n raised to 2 plus n plus 1 plus 1 points overall or in total. So, ito na yung magiging total points ng isang projective plane, no? So, substitute na naman natin ulit since yung plane daw have order of 2. So, yung n, papalitan naman ulit natin ng 2. So, 2 raised to 2 equals 4 plus 2 plus 1 equals 7. So, ang plane natin ay mayroong 7 points in total, which is dun to sa Turing 2 na diniscuss sa atin ni Miss Miriam. So, ayun lang guys, yun lang yung plane. Maraming salamat sa pakikinig sa report namin. So, hanggang dun na lang po yung report namin. Salamat po. Bye-bye.